Hello everyone, welcome to this session. In this session, we are going to discuss Laplace transform of integration of f of t. That is, Laplace transform of integral 0 to t f of u du. We are going to prove this result and also we solve some examples based on this formula. So let us see Laplace transform of integration of f of t, or sometimes you may find f of u. So that is Laplace transform of integral 0 to t f of u du, which is equal to 1 upon s f of s. That is f of s upon s, where f of s equal to Laplace transform of f of t. So here Laplace transform of integration of f of t or f of u is defined as Laplace transform of integral 0 to t f of u du equal to 1 by s f of s, which is equal to f of s by s, where f of s equal to Laplace transform of f of t. Let us prove this result. Here, consider or let phi of t equal to integral 0 to t f of u du, and phi of 0 equal to 0. Then phi dash of t equal to phi dash of t is nothing but phi dash of t equal to d by dt of integral 0 to t f of u du. That is, integration and this differentiation will get cancelled. You get f of t. Because here limits are 0 and t. Here upper limit is f of t and lower limit is 0. So here we get f of t because f of 0 is 0. Now, if we take Laplace transform on both sides, Laplace transform of phi dash of t equal to, according to formula of Laplace transform of derivative of f of t, we get s into Laplace transform of phi of t minus phi of 0. Here, which is equal to s into Laplace transform of, here phi of t is nothing but integral 0 to t f of u du. So, 1 by s into Laplace transform of phi dash of t equal to Laplace transform of integral 0 to t f of u du. Now, phi dash of t is nothing but f of t. So here L of f of t, 1 by s into L of f of t equal to Laplace transform of integral 0 to t f of u du. That implies Laplace transform of integral 0 to t f of u du equal to 1 by s. L of f of t is nothing but f of s. So 1 by s f of s. This is proof of Laplace transform of integral 0 to t f of u du, which is equal to 1 by s f of s, where f of s equal to Laplace transform of f of t. So let us see its working method. If we want to solve some problems based on this formula, first you have to identify given function. Working method to solve problems. First one, given question may be in the form of integral Laplace transform of integral 0 to t f of u du or Laplace transform of integral 0 to t f of t dt. If you find this type, then write f of u, what is given function, and put u equal to t, then you get f of t. To get f of t. If question is in this form, directly we get f of t. So here write f of t equal to given function. Write f of t equal to given function. Now, according to this formula, we know that Laplace transform of integral 0 to t f of u du or Laplace transform of integral 0 to t f of t dt. Question may be in any form, which is equal to 1 by s into f of s, which is equal to 1 by s into L of f of t. So, find L of f of t. Then write the answer as 1 by s into L of f of t. So here, after getting, first we have to identify the function, then we have to find the Laplace transform of that function, then final answer will be 1 by s into Laplace transform of f of t, that is 1 by s f of s. So you have to follow these 3 steps to solve problems based on this formula. Now let us see some examples. First one, find Laplace transform of integral 0 to t e power minus t into cos t dt. So here, this is in the form of Laplace transform of integral 0 to t f of t dt. So here, f of t equal to, this is just like integral 0 to t f of t dt, which is equal to 1 by s f of s, that is 1 by s into Laplace transform of f of t. This is formula. Now compare these two, given question and LHS of this formula or this equation. Then we get f of t equal to e power minus t into cos t. So after identifying f of t, we have to find Laplace transform of f of t, that is Laplace transform of e power minus t into cos t. This is equal to, here you have to apply Laplace transform of e power minus at cos bt formula, which is equal to s plus a by s plus a whole square plus b square. Now we have to apply this formula. According to this formula, here a is 1, b is 1. So we get Laplace transform of e power minus t into cos t equal to s plus 1 by s plus 1 whole square plus 1 square, that is 1. So here we get s plus 1 by s plus 1 whole square plus 1. Now this is L of f of t, that is f of s. L of f of t is nothing but f of s. So f of s equal to s plus 1 by s plus 1 whole square plus 1. So Laplace transform of integral 0 to t e power minus t into cos t dt equal to 1 by s f of s, which is equal to 1 by s into s plus 1 by s plus 1 whole square plus 1, that is s plus 1 by s into s plus 1 whole square plus 1. This is Laplace transform of integral 0 to t e power minus t cos t dt. Now let us see one more example. Find Laplace transform of integral 0 to t sin at upon t dt. So here again this is in the form of integral 0 to t f of t dt, which is equal to 1 by s f of s. If you compare LHS of this equation and given question, we can identify f of t equal to sin at upon t. Now we have to find Laplace transform of f of t, that is equal to Laplace transform of sin at upon t. Here to find Laplace transform of this, we have to apply the formula of Laplace transform of f of t by t, which is equal to integral s to infinity L of f of t ds. We have to apply this formula to find Laplace transform of sin at by t. So here Laplace transform of sin at upon t equal to integral s to infinity Laplace transform of sin at ds. Here I have replaced f of t by sin as. Now we have to apply Laplace transform of sin at formula here. So Laplace transform of sin at equal to a by s square plus a square. If you apply this formula here, you get integral s to infinity a by s square plus a square ds. Now which is equal to a into integral s to infinity 1 by a square plus s square ds. Now to integrate this, we have to apply integral 1 by a square plus x square dx, which is equal to 1 by a tan inverse of x by a. We have to apply this integration formula to integrate this. So here we get a into 1 by a. Here the a which is existing in numerator, I have taken it outside this integral. So we got 1 here in the numerator. Now this is similar to this formula. So if you apply this formula, we get 1 by a tan inverse of s by a under the limits s to infinity. So you can take even 1 by a outside, 1 by a. Here tan inverse of s by a under the limits s to infinity. Here a will get cancelled. We get tan inverse infinity, which is equal to tan inverse of infinity minus tan inverse s. s by a. So here tan inverse of infinity minus tan inverse of s by a, which is equal to tan inverse of infinity is pi by 2. So here we get pi by 2 minus tan inverse of s by a. But here pi by 2 minus tan inverse s by a. Pi by 2 minus tan inverse theta equal to cot inverse theta. So we get cot inverse of s by 2. Now this is Laplace transform of sin at by t. Now we want Laplace transform of integral 0 to t sin at by t dt, which is equal to 1 by s into Laplace transform of sin at by t according to that formula. So 1 by s into cot inverse of s by a. Here this is s by a. Cot inverse of s by a. So here pi by 2 minus tan inverse s by a gives cot inverse s by a. But this is Laplace transform of sin at by t. To get Laplace transform of integral 0 to t sin at by t dt, we have to multiply this by 1 by s. So we get 1 by s into cot inverse of s by a. This is the final answer. Let us see one more example. Find Laplace transform of integral 0 to t cos at minus cos bt upon t dt. Now write that formula Laplace transform of integral 0 to t f of t dt, which is equal to 1 by s f of s. Now write given function f of t equal to, by comparing these two you can write given function f of t equal to cos at minus cos bt upon t. Now we have to find Laplace transform of this given function using the formula Laplace transform of f of t by t. So Laplace transform of f of t by t equal to integral s to infinity L of f of t ds. Now Laplace transform of cos at minus cos bt upon t equal to integral s to infinity L of, here if you observe this numerator f of t comes here, Laplace transform of this numerator f of t. Here numerator is cos at minus cos bt. So here within the integral, here you may find Laplace transform of cos at minus cos bt ds. Now Laplace transform of cos at is, here you can apply linearity property. So you can find Laplace transform of cos at minus Laplace transform of cos bt ds. We can find Laplace transforms separately. Now Laplace transform of cos at equal to s by s square plus a square, and Laplace transform of cos bt equal to s by s square plus b square. So Laplace transform of cos at minus cos bt upon t equal to integral s to infinity, here you can write s by s square plus a square, here minus s by s square plus b square ds. Now you can integrate these two separately, or we can integrate without separating these two. But before integrating we have to adjust these two terms. Multiply and divide both these terms by 2. Here 2s by s square plus a square minus 1 by 2 into 2s by s square plus b square ds. Now take 1 by 2 outside. So 1 by 2 into integral s to infinity 2s by s square plus a square minus 2s by s square plus b square ds. Now we have an integration formula, integral f dash x by fx dx equal to log of fx denominator. So if you find these two terms, here d by ds of s square plus a square equal to 2s. In the same manner, derivative of s square plus b square is also 2s. That means here in this ratio, numerator is nothing but derivative of the denominator. Here also numerator is derivative of the denominator. So we can apply this integration formula here. Then we get 1 by 2 into, here if you integrate this first term, we get log of fx. Fx means here denominator. So here in this first term, you get 1 by 2 into log of, if you integrate this, you get log of s square plus a square. And integration of second term is log of s square plus b square under the limits s to infinity. But before applying these limits, let us simplify this bracket. Here we have to apply log a minus log b formula, which is equal to log of a by b. If you apply this formula here to simplify this bracket, you get 1 by 2 into log of s square plus a square upon s square plus b square under the limits s to infinity. Here also we can't apply this upper limit directly because infinity plus anything will be infinity only. So let us simplify again. Let us take s square common in the numerator as well as in denominator. So in numerator, if you take s square common, you get 1 plus a square by s square upon here s square into 1 plus b square by s square. Now s square will get cancelled. Here limits are from s to infinity. Now let us apply limits. Here log of 1 plus a square by infinity upon 1 plus b square by infinity, because whenever you apply upper limit, you have to replace s by infinity. You have to put s equal to infinity. Minus, you put s equal to s. Here independent variable is also s and lower limit is also s. So this expression will not change. Log of 1 plus a square by s square upon 1 plus b square by s square. So here anything upon infinity is 0. So here you get log of 1 plus 0 by 1 plus 0 minus log of, here again let us take LCM, s square plus a square by s square upon s square plus b square by s square. Let us take LCM in both numerator and denominator. Here these two denominators will get cancelled. Here you get 1 by 2 into log 1 minus log s square plus a square upon s square plus b square, which is equal to 1 by 2 into log 1 is 0. So here you get 0 minus log s square plus a square upon s square plus b square, which is equal to minus 1 by 2 log s square plus a square upon s square plus b square. This is nothing but 1 by 2 log s square plus b square by s square plus a square. So if you want to remove this negative sign, we consider reciprocal of this. How? Here minus sign you can take in this power, because m log n minus m log n equal to m log n power minus 1, that is m log 1 by n. So by this formula we can write reciprocal of s square plus a square by s square plus b square to eliminate this negative sign. So this is Laplace transform of cos at minus cos bt upon t. But here we have to find Laplace transform of integral 0 to t cos at minus cos bt upon t. So to get Laplace transform of integral, to get Laplace transform of integral 0 to t cos at minus cos bt upon t dt, we have to multiply this result by 1 by s. So 1 by s into 1 by 2 log s square plus b square upon s square plus a square, that is 1 by 2s into log of s square plus b square upon s square plus a square. This is Laplace transform of integral 0 to t cos at minus cos bt upon t dt. So let us see one more question. Find Laplace transform of integral 0 to t e power t sin t upon t dt. As usual, according to our formula, integral 0 to t f of t dt, which is equal to 1 by s f of s. Now if you compare these two, you find f of t, which is equal to e power t sin t upon t. Now f of s is nothing but Laplace transform of f of t. So here, which is equal to Laplace transform of e power t sin t upon t. To get its Laplace transform, again we have to apply Laplace transform of f of t by t formula, which is equal to integral s to infinity L of f of t ds. Now Laplace transform of e power t sin t upon t equal to integral s to infinity Laplace transform of this numerator, that is e power t sin t ds. Now to get Laplace transform of e power t sin t, you have to apply Laplace transform of e power at sin bt formula, which is equal to b by s minus a whole square plus b square. So according to this formula, Laplace transform of e power t sin t equal to, how do you get this? Identify values of a and b given in given expression. Here a equal to 1, b equal to 1. So here replace a by 1 and b by 1. So 1 by s minus 1 whole square plus 1 square, that is 1. Now Laplace transform of here e power t sin t upon t equal to, what to do? We have to integrate this, integral s to infinity 1 by, here you can write it as 1 plus s minus 1 whole square ds, because here according to this formula, here first we have evaluated this Laplace transform of e power t sin t. Then to get Laplace transform of e power t sin t upon t, we have to integrate this Laplace transform with respect to s under the limits s to infinity. So here to integrate this, you have to apply integral 1 by 1 plus x square dx formula, which is equal to tan inverse x. Now here you get tan inverse of s minus 1 under the limits s to infinity, which is equal to tan inverse infinity minus tan inverse of s minus 1, that is pi by 2 minus tan inverse of s minus 1, which is equal to cot inverse of s minus 1. Now Laplace transform of integral 0 to t e power t sin t by t dt equal to 1 by s into Laplace transform of e power t sin t upon t, which is equal to 1 by s cot inverse of s minus 1. So this is Laplace transform of integral 0 to t e power t sin t upon t. So in this session we have discussed formula of Laplace transform of integration of given function f of t and its proof, and we have solved 4 examples based on this formula. In next session, let us see some more examples on this formula. Thank you.